All right, let's talk about how to answer these. So remember, when trying to come up with a name for a formula, your first thing you need to do is to identify which category of chemicals the formula falls into, because different categories of chemicals have different names, and you need to make sure you apply the correct name according to the category it is. So we'll say, let's see, I for ionic. We'll say M for molecular, aka non-ionic. And we'll say A for acids. So these are the three categories of chemicals because these are the three types of naming rules that we have looked at. So first one on the list, it's an acid. Acids start with H. So this is an acid. And speaking of acids, what else starts with H? That's an acid. And that's an acid. All right, next up here, ionic. How do I know this is ionic? Remember, ionic compounds contain a metal plus a nonmetal. So remember that the metals are all this section of periodic table over here. Nonmetals are hydrogen and these things over here in this corner. So I note that this contains a metal and sulfur and oxygen are nonmetals. In addition to that, there's also the fact that SO4 is sulfate, a polyatomic ion. And obviously, if it contains a polyatomic ion, it is an ionic compound. So that's ionic. There are no metals here at all. This is just nonmetals. So this is molecular. That's a metal. There's some polyatomic ions. Ionic. Metal, nonmetal. That's ionic. Nonmetal and nonmetal. Iodine and oxygen are both nonmetals. So that's molecular. A metal and a nonmetal. That's lead. Lead's a metal. Hopefully everyone knows metals. Lead's a metal. So that's ionic. CH4, hydrogen's a nonmetal, carbon's a nonmetal, so that is molecular. And then nitrogen and oxygen are both nonmetals, so they are going to make a compound that follows the molecular naming rules. So, well, okay. Let's start with the ionic naming rules. Calcium and sulfate. Calcium has a constant charge, so it is therefore calcium sulfate. No Roman numeral needed because it's a constant charge. Next ionic one is chromium and carbonate. Chromium has a variable charge, so we need a Roman numeral. Let's see, each one of these is a -2 charge. There are 3 of them for a total -6 charge, which means the chromium must be a +6 charge. So we're going to call this chromium 6 carbonate. Next, we look at another ionic one, that is silver. Silver is a +1 charge. Gotta memorize that. No Roman numeral needed. Silver, and this is phosphide ion, so phosphide. Next ionic one, lead and sulfur. Lead has variable charge. It is not one of the ones that we know a charge for regularly, so sulfide is a -2 ion, therefore the lead must be a +2. So we're going to call this lead, Roman numeral 2, sulfide. Or we just say it as lead 2 sulfide. All right, that's all the ionic ones on this list. Let's do molecular next, since that was presented in that order in the class, first ionic, then molecular. All right, 2 carbons and 6 bromines. So that's dicarbon, hexabromide. An iodine and an oxygen. This is our next molecular thing. Iodine. Oops, I misspelled that. Iodine. And then oxide. And 2 of them, so dioxide. There's 1 iodine, but you don't put mono because you never put mono for the first thing. Only mono if there's 1 of the second thing. All right, this one. Normally you would say carbon tetrahydride. However, CH4 has a special name, methane. Make sure you memorize that. All right, N2O3, dinitrogen trioxide. Remember, the second one always ends with I. The first one is just the element name. All right, that's all the molecular ones. Now for the acids. Contains no oxygen, so it starts with hydro. Bromine is the element, so bromic. and add acid because it starts with H. This one contains oxygen, so do not start with hydro. It's based on the name of the polyatomic ion. This is carbonate. And because carbonate, remember, if you ate an ion, you would say ic. So carbonic acid is the name. Let's see, last thing on the list, HNO3. This is nitrate. Remember, if you ate an acid, you would say ic. So this is nitric acid. Again, it contains oxygen, so do not start the name with hydro. Had this been H3NO2, it would have been nitrite, and then it would have been nitrous acid. All right, so that's how you do come up with the names if given the formula. Now let's come up with a formula if given the name. Tetraphosphorus triselenide. Tetra means 4. So P4. Selenide refers to selenium, which is this one right here. So P4 Se3. Potassium acetate. So let's see, potassium is a plus. Acetate is C2H3O2 minus 1 potassium, 1 acetate. So K C2H3O2. Iron 2 phosphide. So that means iron with a 2 plus charge. Phosphide means just P3 minus. So that means 3 irons in the formula, 2 phosphoruses. Fe3P2. Next, disilicon hexabromide. Silicon, Si, bromine, Br, disilicon is 2, hexabromine is 6. Do not reduce this. This is a molecular formula, which means it tells you how many atoms are actually in the formula of the molecule itself. So if it says 2 and 6, leave it as 2 and 6. Do not attempt to reduce this to 1 and 3. All right, next, titanium 4 nitrate. Titanium with a +4 charge. Nitrate is a polyatomic ion with a minus charge, telling you that when you switch the charges, it's going to have 1 titanium and 4 nitrates. So let's give it 1 titanium and 4 nitrates. There's nitrate and there's 4 of them. All right, that's what it looks like. Next, chloric acid. This is going to start with H because it's an acid. And then chloric. Remember, if you ate an acid, you would say ic, so chlorate. And the fact that it doesn't start with hydro tells you there's oxygen. So it tells me that this is a polyatomic ion based on chlorate. So HClO4. Now, just to check, to justify, is that the right formula? H is a plus charge, ClO, sorry, I made a mistake. HClO3. ClO3 is a minus charge, so I put 1 here and 1 here. My formula should have 1 hydrogen and 1 chlorate, which I do indeed have, so that's the answer. Next, copper 1 phosphate. That's copper with a +1 charge, and phosphate is PO4 with a 3 minus charge, meaning that in the formula we need to have 3 coppers and 1 phosphate. So let's put 3 coppers and 1 phosphate. Remember, 1 polyatomic ion means no parentheses needed. Same here, same here. All right, next, zinc oxide. You have to memorize zinc is a +2, oxygen is a -2, which means you have 2 zincs and 2 oxygens in the formula. So Zn2O2 reduces to ZnO. Therefore, ZnO is the formula for zinc oxide. Next, chloric acid. Remember, if you had, well, first of all, if it's an acid, it starts with H. And the fact that it doesn't start with hydro means that this one is going to contain oxygen. So it's a polyatomic ion. Remember, if that polyatomic ion starts with 8, then the acid's name is ic. But since it isn't ic, then it doesn't start with 8. It starts with us. Or sorry, the acid's name is going to involve us, which means the polyatomic ion must involve the ite ending. So if the polyatomic ion involves the ite ending, then we have to say chlorite. So chlorite is ClO2 minus. So HClO2. Now ClO2 minus and H plus, that's going to give you 1 chlorite and 1 hydrogen in the formula, so we can just leave it like that. Next, ammonia. You got to memorize that. NH3. That's it, NH3. All right, hydrochloric acid. Hydro means no oxygen in the formula. Acid means starts with H. So no oxygen starts with an H based on chlorine. So chlorine is a 1 minus charge, starts with hydrogen. Hydrogen's a plus. So 1 chlorine, 1 hydrogen in the formula, HCl. All right, that's how you do it.